All right. So after you have answered those 6 questions and you've thought through the way that your experiment's going to run, somebody's going to come up to your table. So when we run this experiment, we'll have the class go around to the tables. We'll have 6 taste testing tables tomorrow, and then the next day will be the 6 beauty product tables. Okay. So envision somebody coming up to your table and how it's going to look, how they're going to choose their product to sample. So let's talk about that. Because the second component to experimental design is randomization. Control, randomize, repeat. Well, we have to have a form of randomization in an experiment. So now, random selection is when you randomly select from the population, then you say, hey, I think this is a random selection of people from the population, so they're like the population that we want to generalize to. So we need to see, we obviously did not randomly select your class period to be, as a random selection from Aledo High School students, but maybe you would consider your class representative of all AHS students, Aledo High School students. We don't know. So that's one thing that in a moment you're going to consider. You're going to discuss with your partners or partner. Do you consider your class to be representative of all Aledo High School students with respect to your product? Maybe the person doing the Oreos thinks, yeah, I don't think that our class is going to have a particular opinion about Oreos differently from the rest of Aledo High School. So I think that we might be a representative sample that we could generalize to all Aledo High School students. Now, I don't think I would go generalizing to all students because, you know, we might have different tastes in this area, or our families choose different things than other areas of the state or the country or whatever, or certainly the world. So I certainly don't think I would go past generalizing to much more than Aledo High School, maybe even not Parker County, probably even. But who do you think you can generalize your findings to? Explain. All right, so the next question. In an experiment, you must have random assignment. You must randomly assign to the treatment group so you can claim the cause and effect. So that was one of the songs and one of the criteria that we discussed. Random assignment must happen. It's an essential principle to be able to claim cause and effect. In our experiment, however, we cannot randomly assign some subjects to sample the name brand and some subjects to sample the generic. Everybody has to sample both products. Hopefully, you figured that out on problem number 1 on the previous page. In order for that comparison to be made and a preference to be concluded. So, how do you think we can have random assignment come into play in our experimental design if people are going to be using and sampling both products? So I want you to think about that. How could there be random assignment? This next question might kind of lead you into that answer. So let's read that. State specifically how you will implement this random assignment. In other words, when a subject comes to your table to test your products, how will you randomly assign the subject to the treatment that will be sampled first? Ding, ding, ding. That's the clue. Think about toothpaste and orange juice. If you brush your teeth first, then it doesn't matter how good the orange juice is, it tastes horribly. But if you have the orange juice first, then it'll taste good. And then you can go and brush your teeth and you're all fine and dandy. So the order in which you sampled the products might have an impact on the preference. Therefore, that is what needs to be controlled or randomized so that that is then not an issue. All right. So you're going to brainstorm. How are you going to do that? A person's going to come to your table. How are you going to randomly do this? Now, suppose you choose coin flip. Suppose you say something like, hey, somebody comes to our table. We're going to let them flip a coin. And if the coin lands heads up, then we're going to let the subject test the name brand product first, and then the subject, then the generic. But hey, if they flip the coin and they get tails, then maybe we'll let them do the generic product first. Okay, so if you did that, technically speaking, could you just happen to have a whole lot of people who flip the coin and land heads up? And maybe most of your people in your group end up sampling the name brand product first? That could be a problem. So when you decide how you're going to randomize to which product they taste first, how can you make it so that you don't have too many subjects sampling one particular product first? How can you make it pretty close to 50-50, if not exactly 50-50? All right, so you're going to think about that. And let's go ahead and talk about this last part, and then that'll be the end of the videos. You will then finish through these problems, 10 for sure, if not 11 as well. And then you will take that picture and upload that into Canvas, and then we will do our sampling tomorrow. All right. So control, randomize, repeat. The last component is repetition. So the final principle in experimental design is repetition. You cannot just take the results from one subject and say, oh, voila, that person chose the generic, so the generic must be better. No, you cannot. You must have repetition. So what is the way that we will be having repetition in our experiment? So you will write that down there. Now, do you remember, see this picture I have over here? This was when we did our blue M&Ms, and you all had your own little pea hat, and you all got your own little cup of M&Ms, and you all did your own little proportion of M&Ms that were blue, and you put that on here. Well, we found that this sampling distribution came out to be approximately normally distributed if the sample size is large enough. You remember how we've been talking about needing to meet a minimum size? That's what number 11 takes into account. So we need to make sure that our sample is large enough to be able to be considered a representative sample and have data that is large enough so that this sampling distribution will be shaped approximately normally. So remember that if the products are preferred equally, then the name brand product will be chosen approximately 50% of the time. So the P in our null hypothesis is going to be 0.5. Okay. If you look at the top of the next page here, that is again needing to meet the minimum sample size needed. Okay. So we need N times P, and remember that your P is 0.5. So fill that in and solve for the sample size. So we need to make sure that we have at least that many sampling your product when we run our tests, taste test tomorrow and beauty product test the next day. And then eventually we will be doing a test. We'll be doing a statistical test to see if it was sampling variability or if there really is a preference for the name brand. Okay, and then of course, eventually we will be doing a product presentation project of your results and your data collection and what all happened, and we'll talk about that after we finish our products. All right, So I want you to finish making sure you have completed all of the problems 1 through 10 and answered those, and then upload that into Canvas for your assignment for today. All right, I hope you have some good ideas about how to conduct your experiment.